The Pinzgauer 712 has a reputation as one of the most capable six-wheel drive platforms ever built for rough terrain. Enthusiast forums call it indestructible, but a reputation is not a specification sheet. On DecayAudit, our job is to take that reputation apart, line by line, and check it against documented engineering sources. Today we are auditing the single mechanical idea that sits underneath almost every claim made about this truck. It's portal axle, independent swing axle suspension. We will show you exactly what the record supports and exactly where the record runs out. Let's start with the mechanism itself. The Pinzgauer uses portal axles, the same basic principle used on the Mercedes-Benz Unimog, specifically to provide extra clearance over obstacles. In a portal axle, the axle tube sits above the center line of the wheel hub, and power reaches the wheel through a small reduction gearbox built into the hub itself. That single geometric shift is what raises the lowest point of the drivetrain without raising the entire vehicle body. It is a simple idea on paper. The engineering discipline is in how the rest of the chassis is built around it. It is worth pausing on why that comparison to the Unimog matters for this audit. Both platforms come out of the same post-war European tradition of building all-terrain trucks for military and agricultural use, and both arrived at the portal axle solution independently of ordinary passenger car engineering. That convergence is a signal, not proof by itself, that the portal axle approach solves a real problem rather than being a marketing gimmick. But signals are not the same as verified specifications, and this audit is only going to lean on what the documented record actually states. That surrounding structure is a central tube chassis. The documented design uses a central tube chassis with a transaxle that distributes weight more evenly and keeps the center of gravity as low as possible. Notice what that claim does and does not say. It documents a weight distribution and center of gravity design intent tied to the backbone tube layout. It does not, on its own, hand us a numeric roll stability figure or a published rollover threshold. We record the documented design intent as exactly that. A documented design intent, not a lab-tested stability rating. Now the number everyone actually wants. Ground clearance. The vehicle is documented with fully independent suspension and 335 millimeters, or 13.2 inches, of ground clearance at the lowest point when fully loaded. That is not a single, isolated figure either. An independent technical data sheet for the 712M 6x6 variant lists ground clearance of 33.5 centimeters, also 13.2 inches, measured below the axle housing when loaded. Two separately published sources, one an encyclopedic reference and one a standalone technical data sheet, land on the same measurement to the millimeter. In an audit like this, that kind of independent corroboration is exactly what turns a single claim into a documented fact. So what does that clearance number actually buy the vehicle, mechanically? Here we have to be careful about the line between documented fact and reasoned inference. Combining the documented portal axle clearance mechanism with the independently corroborated 335 mm figure, the portal axle and independent swing axle geometry are the primary engineering reasons the Pinzgauer 712 achieves higher ground clearance and wheel articulation than contemporary 6x6 platforms using solid, non-portal axles. We are flagging that claim explicitly as an inference, not a manufacturer-stated fact. It is a reasoned conclusion built from two verified data points, and any specific comparison to a named competing platform would need its own dedicated sourcing before we would state it as fact. Every engineering choice has a trade-off, and this is where the audit gets interesting. The Pinzgauer's independent axles are swing axles, and swing axle geometry carries a well-documented structural limitation. One problem inherent in the swing axle concept is that it almost inevitably results in a very high roll center, which causes detrimental jacking effects and camber change when cornering and lateral cornering forces are applied. In plain terms, as the suspension unloads in a hard corner, the outer wheel's contact patch can tilt away from the road exactly when you need grip the most. This is not a Pinzgauer-specific flaw. It is a known characteristic of the swing axle family of suspension designs, and it is the same structural trade-off that shaped rear-engine handling debates on other vehicles entirely. For an off-road platform built around low-speed articulation over broken ground, the trade-off reads very differently than it would for a highway sedan, but the underlying geometry is identical either way. Think about what that means operationally. On a rutted forest track or a rock ledge at walking pace, jacking and camber change are largely irrelevant because lateral cornering loads at those speeds are small. The independent swing axle is instead doing exactly the job it was designed for, letting each wheel travel through a large arc independently, so all 6 wheels can stay in contact with wildly uneven ground. The same geometry that would be a liability in a sustained high-speed corner becomes an asset the moment the vehicle is moving slowly enough that lateral load is not the dominant force. That is the core engineering tension this audit is built around. 1, suspension geometry, 2, completely different operating envelopes, and 2, completely different verdicts depending on which envelope you are asking about. Now the part of the audit most channels skip. What does the current source ledger not establish? We have not yet verified engine displacement, output, or torque figures for the 712 against an approved primary source, so we are not going to quote horsepower numbers in this episode. We have not verified payload capacity, towing figures, or fording depth against an approved source either, even though preliminary research turned them up. And critically, we have not verified any documented failure rate, maintenance interval, or field reliability data for the swing axle hub seals under sustained articulation. Reputation on forums is not the same as a maintenance record, and until that record is sourced and approved, we treat long-term durability as an open question, not a conclusion. So where does that leave the Pinzgauer 712, engineering-wise? The verified record supports 3 solid facts: portal axles engineered specifically for obstacle clearance, a central tube backbone chassis designed to lower center of gravity through even weight distribution, and a fully independent suspension delivering 335 millimeters of loaded ground clearance, confirmed by 2 independent sources. It supports 1 clearly labeled inference connecting that geometry to comparative off-road capability, and it supports 1 clearly documented structural trade-off: the jacking effect inherent to swing axle geometry, which is the price paid for that independent articulation. That is the honest engineering picture: a documented clearance advantage, a documented structural trade-off, and a research ledger that still has open questions about engine output, payload, and long-term hub durability. We will keep pulling on those threads in a future audit. Until the sourcing catches up, we are not going to fill the gap with forum folklore. That is how we keep this channel's engineering honest. If you have hands-on experience with a Pinzgauer swing axle hubs, particularly service records on seal life or articulation, where that is exactly the kind of primary evidence this audit needs before the open gaps can move into the verified column. DecayAudit exists to separate documented engineering from repeated folklore, 1 claim at a time, and a 6-wheel drive platform this well-regarded deserves a source ledger that actually earns the reputation. Thank you for watching DecayAudit.